Well, howdy and welcome to Geometric Series Part 1. Now, to start us off, I wanted to show you the difference between a sequence and a series. Now, suppose we take an example of a geometric sequence where we have, say, a term like 1, and maybe we're going to times that by 2, so the next term is 2, and times it by 2 again, the next term is 4, and so on. Now that's a sequence, which is a list of terms. But suppose we want a series. Well, the series is to add the same kind of terms that are going to double every time, but we're going to add them together. So we're adding up the terms, and that's the difference. That's a series. And what typically we do with a series is we look at what we call partial sums. So the sum of just one such term, well, that would be 1. And if I was going to add the first two terms together, well, that would be 1 plus 2, which is 3. And then I could add together 3 terms, so 1 plus 2 plus 4, and that's 7, and so on. So that's kind of where we're going with this. Now, what we would like ultimately is maybe some way that we can develop a formula to add up n terms. I mean, we know theoretically what it would be, what we're doing here, but what if this was some big number, like say we were going to add up the first 37 terms? You wouldn't want to be doing it this way because it just takes you too long. So that's what we're going to do now. We're going to develop the formula. So I'm going to clear the screen, show you what we got. So to do this, I am going to just generalize what this partial sum actually is. And what it is, it's our first term plus our second term. Now, these are geometric, so the second term would be a times r. Okay, and then our third term would be a times r again. Okay, and so on until finally we get to our last term, which would be a times r raised to the n minus 1. Okay, so that's going to be our last term. Now here's the trick to this thing. What we do is we're going to multiply both sides of this equation by the common ratio r. So it's going to look like this. R times this sum, whatever that is. And here we're going to have r times all of these terms. So there's an a, then there's the ar, then there's the ar squared, and so on until we get to our last term. Okay. Now, each of these terms, I'm going to expand out the brackets here and see what I get. So I'm going to get r times a, which is actually just ar. Then I'm going to have an r times an ar. So that's ar squared. Then I'm going to have the r times the ar squared, which is ar cubed, and so on until, what's my last term going to look like? Well, let me just write the whole thing out so you can see what's going on. It's a times an r to the n minus 1. Now let's put these two guys together because they have the same base of r. And remember, there's an invisible 1 here. Now the rule when you multiply together powers that have the same base is you're supposed to add your exponents. So that's like saying that this is a times r to the 1 plus n minus 1, which would simplify down to a times r just to the n, right? Because you got your 1 and your negative 1, which cancel. So this is what our last term would look like. Now all of this kind of got a little bit messy here, but I think we can sort of carry on. We've got a little bit more room here. What I'm now going to do is subtract the second equation here from my top equation. So here's what it looks like on the left side. That's the easy side. I have s sub n minus the term below it, which is r times s sub n. And on the right side, well, I've got all these terms here, so on the top, and I'm going to put brackets around them just for clarity. I have a plus ar plus ar squared, and then all the stuff in the middle, plus ar to the n minus 1. So there's my top terms, and then I'm going to minus all the terms on the bottom here. So there's an ar, then there's an ar squared. Now I'm going to run out of room, so I'm just going to go dot, dot, dot. And then the last one here is the ar to the n. Ar to the n. Okay, so that's what I'm doing here. And you might not see it right away, but there's actually a lot of terms here that you could combine. Not so much on the right side, but the only thing we can do on the right side is factor out s sub n. It makes life a little bit easier, so we get a 1 minus r. Now, what about all these terms that are sort of like terms on the right? Well, there's only one a. There's nothing we can combine with that a, so that's this guy here. But here I have a positive ar, and over here I have a minus ar. Well, guess what? These guys, they cancel. Then I got a positive ar squared, and over here I have a minus ar squared. So guess what? Those guys cancel. And in fact, everything in the middle here is going to cancel with all of these terms, even this guy here. There's going to be a term just ahead of this guy which cancels with them. But this guy here at the end, there's no ar to the n. So this guy's on his own, but it is a negative. So it's going to be minus ar to the n. Okay, so that's what it actually boils down to, which isn't all too bad, because now what I can do is I can divide both sides by 1 minus r. So it's going to look like this. See if we can squeeze it in here. Now typically on the right side what they do, actually I'll do it in 2 steps so I don't lose you here. So we got that stuff. We're going to divide all of that by 1 minus r. Now typically we don't leave it that way. What they do is they factor out the a. So then you have a 1 minus r to the n all over 1 minus r. And I'm going to say or, because sometimes what they do is they'll spin around the stuff in the brackets on the top and the stuff on the bottom. Just in case you're wondering, well, where's this coming from? That's what it is. They spin it around, so you get the choice. If you really want to, you can do it in this order, as long as you spin them both around. Okay? And there it is. There's our formula for getting the sum of n geometric terms. And that's where I'm going to stop. And what we're going to do is we're going to pick it up with some examples using this very wonderful formula.